All right, guys, welcome back. So in our last couple of explainers, we basically built the house, right? We've got TCP for the reliable pipes, TLS to make sure they're secure, and DNS to give us a solid address. But what's the point of a house if you can't even get in the front door to, do stuff?
Exactly. We need a shared language, right? A menu that everybody can read, a set of rules that both you and the pizza place understand. We need a contract. And that brings us to Chapter 5, APIs, Application Programming Interfaces. This is how the web actually works.
Look, in any distributed system, your API is your front door. It's the public face of your entire service. And if that door is messy, if it's inconsistent or just plain unpredictable, your clients are going to have a bad time. And trust me, you are going to have bugs. So let's start with the most basic rule of this contract.
So here's the crucial point. Stateless means every single request has to be its own self-contained little package. It has to carry all the information the server needs to do its job, because the server has zero memory of who you are or what you asked for a second ago. It's kind of like calling a customer service line and getting a brand new agent every single time you call back.
Every single request you send, doesn't matter if it's from your browser or another service, is made of these four parts. You've got the verb, which is the action, like get or post. The path, which is the thing you want to act on, like /users/123. Headers give it some context, and the body, well, that's your data payload. It's simple, but it's incredibly powerful.
And I love this because it just pulls back the curtain on all our fancy tools and libraries. Underneath it all, HTTP 1.1 is just plain text. And when things inevitably break and your high-level tools are just giving you garbage, remembering this raw nature, man, it's a superpower for debugging. You can literally just read the conversation. Okay, so this brings us to the most common API style you're going to see out there, RESTful APIs. In the REST world, everything is a resource. A user is a resource, a product is a resource, you get the idea. And we use those HTTP verbs or methods to tell the server what we want to do to those resources.
And this table, this right here is the contract we've been talking about. Each method has a very specific meaning, a promise. A get promises it won't change a thing. A put or a delete promises that if you send it twice or 100 times, the result will be exactly the same as sending it just once. You have to follow these rules, guys. It's what makes the whole web predictable. And seriously, don't do this. I mean it. The entire internet, search engines, web caches, browsers, they are all built on the assumption that GET requests are safe. They can be rerun, they can be cached, no problem. If you use a GET to delete something, you are violating a core principle that makes the whole system work. Just don't.
Okay, so we've sent our request. It's beautiful, it follows all the rules, the server does its thing. Now, how does it let us know what happened? How's it feeling? Is it happy? Is it confused? Totally overwhelmed? Well, it uses a really simple, elegant system of 3-digit numbers called status codes. If you're a back-end engineer, these are your bread and butter. You gotta know these by heart. A 400-level error, like a 404 not found, that means the client did something wrong. The problem's on their side. But a 500-level error? Oh yeah, that means it's time to check your server logs, my friend, because the problem is on your side.
Now, an API contract isn't just about one request and one response. It's a long-term relationship. It's about making your API usable and stable for the long haul, so you don't break things for all the people who rely on your service.
Come on, we've all seen it. That sad, dusty Word document on a shared drive somewhere that's hopelessly out of date. The modern way to do this is with OpenAPI, which you might know as Swagger. It is a formal, machine-readable definition of your API. From one single file, you can automatically generate documentation, client SDKs, even mock servers. It makes the contract explicit and real.
Listen to this. This is so important. Once your API is out in the wild, you can't just change it. That's what we call a breaking change. If you have to do it, you need a new version, like /v2/users. Always evolve in a backward compatible way. You do not want to be the reason someone's pager goes off at 3 in the morning.
Okay, we've arrived. This is the single most important concept in this entire explainer. Seriously, if you remember one thing, make it this: idempotency. Why? Because in a distributed system, over a messy, unreliable network, retries are not an if, they are a when. They will happen, and your API absolutely must be ready for them.
Okay, here's the classic nightmare scenario. The client sends a payment request. The server gets it, processes it, everything is good.
But then, the network just drops the 200 OK success message on the way back. So from the client's point of view, the request failed. What's the most natural thing in the world for that client to do? It's going to retry.
And there it is. Boom. If your API isn't designed for this, your user was just charged $200 for a $100 purchase. This is an absolute disaster for any kind of financial or e-commerce system. This is the very thing we have to prevent.
The solution, the only real solution, is idempotency. We have to design our systems so that requests are safe to retry. Now, methods like get, put, and delete are idempotent by their very nature. But post, the one we use for creating things, that one is not. So we need a special trick to make it safe. And here it is. This is the secret weapon. The client generates a totally unique ID, a UUID is perfect for this, and sends it in a special header. The very first time the server sees this idempotency key, it processes the payment and it saves the result, linking it to that key. If it ever sees that same exact key again, it doesn't do the work twice. Nope, it just looks up the saved result and sends that back. Problem solved.
And that's really the big takeaway from all this. A great API isn't just about slinging some JSON around. It's a design discipline. It's about creating a predictable, reliable contract that is built from day one to expect and gracefully handle the absolute chaos of the network.
So, we sorted out the contract, right? We have the language for our services to talk to each other, but a single server can only take so much abuse. What happens when our app actually gets popular? Well, in our next explainer, we are going to dive into load balancers and reverse proxies, the traffic cops of the internet. You are not going to want to miss it. See you then.